Hello everyone. Welcome to my tutorial on how to ace coding interviews and land your dream job, or maybe just a job for now. Let's not waste any time and get on with this LeetCode 704 binary search. Let's first have a look at the problem statement. Given an array of integers nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with O of log n runtime complexity. So let me give a quick example. So let's say the array input was 13, 2, 15, 10, and let's say the target that we're looking to search is 10. This is just a regular nums array that does not have any pattern, and that's not what is given in the problem. Okay, this is just an example to make you understand how it is different from a linear search or a regular search. So when this is the input and this is the target, right? There is no seemingly deducible pattern that you can that you can use to search for the value of 10, right? So what you'll have to do is you'll have to take each element one by one, compare if it's equal to target, and the runtime complexity of such an algorithm would be O of n, and it's called linear probing. We do not want to follow this because we are like told that there is a pattern that the numbers in this array follows, which is that it is in ascending order, so it's already sorted. So we have to make use of this pattern somehow to identify what the value of where the value of 10 can be found, right? So let's get given an array of integers nums which is sorted in ascending order and an integer target. Write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with O of log n runtime complexity. So let me give a quick example. So let's say the array input was 13, 2, 15, 10, and let's say the target that we're looking to search is 10. This is just a regular nums array that does not have any pattern, and that's not what is given in the problem. Okay, this is just an example to make you understand how it is different from a linear search or a regular search. So when this is the input and this is the target, right? There is no seemingly deducible pattern that you can use to search for the value of 10, right? So what you'll have to do is you'll have to take each element one by one, compare if it's equal to target, and the runtime complexity of such an algorithm would be O of n, and it's called linear probing. We do not want to follow this because we are like told that there is a pattern that the numbers in this array follows, which is that it is in ascending order, so it's already sorted. So we have to make use of this pattern somehow to identify what the value of where the value of 10 can be found, right? So this can be the example that we use for the remaining while doing the remaining problem, right? So let's start by initializing two variables, start and end. They represent the start index and the end index of the search space. Okay, so initially we're looking at the entire array, right? So initially start value is going to be 0 and the end value is going to be length of nums. Okay, once we have these two variables, the main idea is to reduce the a search space with every consecutive search, right? And we are like explicitly asked to come up with an algorithm with log n complexity. And to come up with a log n complexity, how do you think the algorithm will progress? It has to every time reduce the size of the search space by half with every consecutive iteration or with every consecutive search. Basically, the search space is intended to be reduced by half to get a log n complexity. It can be like 1/3 also to the base 3, for example. If the log n to the base 3, in that case, it would be log n to the base 3. If you're going to reduce it by half, in that case, the complexity would be O of log n to the base 2, right? And in this case, binary search, we're going to do such an approach where the complexity would of the end algorithm would be O of log n to the base 2, and by that I mean the search space in every consecutive search or iteration is going to be halved, right? And let's see how that's done. let's um, let's This is the condition, right? We have to make sure that the start is less than end, and let's identify what is the mid index in this new search space every time. So it's going to be start plus end minus start by 2, right? So initially the let's say the length of the array is 6, right? So it's going to be 0 plus 6 by 2, and that is going to be what is 0 plus 6 by 2? The mid value would be 3 initially, right? Initially the mid value is going to be 3, and 0 1 2 3. So this is that index, and we'll be comparing this 12 with the target that we're looking for, and we'll try to see if that's a match. If it's not a match, we'll progress and see how is it related to, or how is it different from target. Is it a bigger value? Is it a smaller value? If it is equal, then that's perfect. We can just return the index, the mid index, right? Because that's where we just compare the value with the target. So if the value is the same as target, we can just return the value of mid. So that's what we'll be writing here. If the nums, if the value at mid in nums is equal to target, then we can just return mid, because we are asked to return the index in this problem, right? And else, if the value is less than target, this is where we're actually using the fact that the number is sorted and it is an ascending order. So let's say the nums of mid, that is this value, is less than target. Then let's assume in this case we have like a value like 16, for example, is the target, and in that case this condition is true, right? Where nums, that is 12, nums of mid, which is 12, is less than 16. In that case, we know that the search space is going to be the right hand side from this mid index. So in that case, we'll be modifying the start or the search space to start from here, and the end would remain the same. Only the start of the search space would modify as mid plus 1, because we'll be starting from here, because we don't have to check this because we already know it's not equal to target. So we can omit it and we can start from mid plus 1, right? In the else case, how do you think will happen? That is the case, for example, when target is less than the mid value, and that's the case when target is 10 and the mid value is 12, right? So in that case, we'll be searching only this, we'll be only searching this for left hand side of the left hand side of this mid value. So in that case, how do you modify the end? We'll be modifying the end of the search space, and that would remain as be modified as mid. So we'll be breaking out of this loop when for example, let's say we're going to have target is going to be 1 and we don't have the number, right? So initially you'll be looking at 12 like we discussed, and now since it is smaller, it would come under this category. And now let's see how the end would modify, right? Let's do that. So in this, initially the, let's say start is equal to 0 and start equal to 0 and end equal to 6, and the mid value is going to be equal to 3. When in the next iteration the start is going to be the same, the end value is going to be modified as 3, and so the mid value would be modified as 3 by 2, which is 1, right? Because 3 by 2, when you round it down to the integer, it is 1. And the first 0, this is the 0th index number, and this is the first index number, which is 5. So now we'll be comparing, when you come to this position, you'll be comparing the nums of mid equal to target, and you'll be comparing 5 if 5 is equal to 1, and that's not the case. So this would not satisfy. Then I'll be checking for this one. This also would not be satisfied. And so in the last case, when nums of mid is greater than target, that is 5 is greater than 1, that is the case. So we'll be looking only at this part, again the end is getting modified to 1. Now the start remains to be 0, and in this case again start is less than end, so we'll be once again computing the value of mid, which is going to be 0 plus 1 by 2, which is 0. And yeah, again you'll be coming here and computing. After this computation is done, you'll be looking at nums of mid, which is nums of 0, which is 2. We'll be checking if it is equal to 1, but it's not true, so you'll be return you would be omitting this part. Now we'll be moving on to this if condition. Nums of mid is less than target. Again, it's not true, so you'll be moving on to this case where end is equal to mid. And in this case, it will be modified as end is only the one that is getting modified. It will be modified as 0 because the value of mid was previously 0, right? And what will happen now is start is no longer less than end. They are equal to. They're equal now. So you won't you would be breaking out of this loop, and in that case we can just conclude that this value is not found, and um, so you have to return -1 as required by the algorithm, right? So this is how you would solve it. And let's see if this runs with the default case 1 and also run with the case 2, which is good. Now let's just, we can also in uh, like try to submit the answer and see what. Okay, it got accepted. That is I would like to point out that binary search is a must know problem for software engineers, and it forms the fundamental logic in many medium and hard level problems. To solve more problems together, please comment, subscribe, and support my channel iCode, and happy coding.